We're now live, coming to you from Los Angeles, California. It's Pat Maddox and Jen Diamond and the RubySteps mob programming team. So let's do a little quick intros. We'll go in the order that I see you, which is Ben, Lucas, Lucci, Nathan, Robert, and then Woody. So Ben, you want to say something? A little intro?
Yeah, hi guys. My name's Ben, and I'm from the UK, and I've mobbed twice before and really enjoyed it. So I'm excited to be here and be mobbing with you guys.
Awesome, Lucas.
All right, I'm from Poland. Nice to meet you all, you guys. And that's my first session. I hope I won't suck.
You'll be fine.
You'll be great. You got a bunch of experienced mobsters already now. So Lucci, what's up, man?
Hey guys, I'm Luchi, and I came from China originally, and I'm now a student at Brown, Providence, USA. So nice to meet you guys.
Hi.
Hey, Nathan.
Ivy League.
Oh, Nathan is no Mike. So Nathan, if I get
Hey.
this right, you're from Australia and you love mob programming because it's fun and you learn a lot. Robert.
Hi, I'm from Los Angeles. I've mobbed with Pat and these guys a bunch of times before, so should be fun.
All right. Woody.
Yeah, I'm Woody Zuill. I'm from near San Diego, California, and I work with the Hunter mob programming team.
I'm Jen Diamond. I live in Los Angeles, down the street from Pat. And I've mobbed with these guys a bunch of times.
Yep. And I'm Pat. All right. So I'm going to share my screen and we will get this show on the road. And I gotta make sure I click on mine. So now, hopefully, Woody, you should be able to. This might be interesting. Are you able to see the screen, Woody?
I do see your screen.
Okay, fantastic. So everybody who is currently watching, you guys should all be able to see the screen. If there's any problems, just send me just send something in the chat, and yeah. So basically, our project for today is we're extending something that we did yesterday, and yesterday we started working on this little tool for managing the basic mob rotation. When we've been doing our mobbing sessions before, we had just kept a text file, and at the end of a timer, we then rotate who's driving and who's navigating. And so yesterday we built this little tool that it stores that rotation in a text file, and we can view the current rotation, and we can tell it to rotate by running a command, and it will automatically rotate. And we actually built a part of something in it yesterday, a little kind of a timer-ish thing, which it doesn't automatically rotate, but it tells us that the time has elapsed and it's now time to rotate. So we're going to be extending that. We came up with some things yesterday that would have been nice to do. We don't really like the structure of the code, and there's some other features that would be really cool. So that's what we'll do. Is we'll kind of extend from what we were doing yesterday. So I'm going to start off just by editing our rotation file and get everybody in here. And I'm just going to go from kind of top to bottom. Lucas, I'm going to put you a little later. I'm going to navigate it first, just to kind of get us going.
Woody, we're trying to build what you have already, basically. Something similar.
Dude, this is awesome. So we got Nathan, Jen, Woody, Lucas. Is that everybody? Did I miss anybody?
Wow. You. Wait,
no, I'm in
there.
there. Okay, cool. So, Jen, can you start a timer for us? Yeah. Do you have a timer? So if you haven't mobbed, I think everybody here has mobbed besides Lucas. So Lucas, you're going to figure out how it works pretty quickly.
All right.
So Ben, you there, ready to drive?
I'm ready to drive.
All right, cool. So if you could please switch over to the other window where we have, this is where we have the code. Okay, so actually switch back to the other window and quit out of Emacs, and that will be our actual runner. And you can quit with Control X, Control C. And if you switch back to the coding window, you can change over to our other buffer with the rotation with Control-X-O, and then revert this buffer to refresh it. And you can, I know people have had problems, so I'm going to take over for just a sec. Now if you type revert-buffer, this is the Emacs command that will reload the file. Yeah, and we're good. Oh, okay, cool. So now hit Control-X0, and that'll close out our rotation file. And so here you can see the code. So let's just briefly walk through. Oh, actually, we haven't seen what it does. So if you want to switch over to the runner window, and you should be able to run Ruby mobrotation.rb. And you need to pass it the rotation text file. And just run that.
Okay.
So this is showing us all the people that are mobbing. It's not yet time to rotate, apparently. And there is one, so this is the basic program that we've got going. So switch back to the code window, and we'll just walk through it briefly. So you see here on this line 3, we're pulling the file name out of a command line argument. And then we're also taking this optional command argument, which tells the program what it's going to do. We've got some stuff for figuring out when our rotation time is and when the last rotation was. This little method show mobsters, which takes all the names and is printing them out to screen. And then finally we have this rotate method, which actually reads, which changes the rotation and then writes it back out to the file and then prints it back out. And I think if we scroll down, I think that might be all the code. Yeah, so there's really two things that are going on. We've got two main methods, this time to rotate method, which tells us that it's time to rotate if we've exceeded our rotation time. And then there's the actual rotate method, which will put somebody from the top of the list to the bottom of the list. And so any questions so far about this? Oh, cool. So a couple things that we came up with yesterday, things that we would like to do. One is that we don't want all these global variables. We use them to get going quickly, but we would like to move this into something more class-like. We also wanted to remove the command line argument of passing the rotation text file to the program so that it automatically looks up the rotation file, and the database could be an optional argument. And then finally, we also, instead of editing the text file directly, we'd like to be able to set up the mob list using the command line program. So those are a couple different things. So I think that we'll use this session as an opportunity to add tests to this code, refactor it, and add some features. Yeah. So the first thing is I would like to store this in Git because we're going to be making some changes and we don't currently have version control. So Ben, if you could please switch back to the code window and initialize a Git repo and add all the files that are in it. You know what? Let's do one thing, which I think before you add the files, I'm pretty sure that do a Git status and see what files it wants to add. Yeah, and we don't want the files, we don't want the backup files. So if you can, actually we want Git to ignore those. So do you know how to ignore those particular text files from Git?
Just pop them in the Git ignore. Yeah. Yeah.
So do a star. So echo the star with the tilde into the Git ignore file, and that will ignore any files that end in a tilde. You're going to need to wrap this in quotes.
The file name.
Yep. So star tilde. Just do star tilde because we don't care about that.
Okay.
Because there's also text files. Cool.
Into Git ignore.
Yep. And then if we do a Git status, we should see that those two are not there anymore. Awesome. So let's add those files to Git and commit, and we are on our way. Love it. Okay, cool. So we are RubySteps. RubySteps at mob1.patmatic.com. I can't think of a better username, so that's cool. So let's head back to the code. And my first, I want to start testing this stuff. And it's going to be kind of hard because it's a batch program and global variables and stuff. So this will be fun and kind of tricky.
Do we test it before, or do we test, or do we refactor it and then test it?
Well, you could go either way, but currently we're dealing with legacy code because we've got working code that doesn't have tests. So I want to start by writing some tests. And I typically like when we're getting started and kind of doing small stuff like this, I just like to keep the tests in the same file. So, well, actually no. So Ben, can you split the window here? And you can do that with Control-X3. And if you pop over to the other buffer with Control-XB, or sorry, Control-XO.
Hey guys.
Yeah, and hey Nathan, welcome. And then, so let's open up a new file and we'll call it mobrotationspec.rb.
How do I do that, sorry?
Control-X, Control-F.
So I'm coming through okay now? So it goes.
Yeah, mobrotationspec.
Okay.
Yep. So let's see, let's make sure we have. So just go ahead and create a single test that is just asserting that 1 equals 1.
Are we using any?
We'll be using RSpec.
Okay.
We're using RSpec so that we can entice Woody to come back for another session where we'll use approval tests. So Ben, do you know how to write individual tests with RSpec?
I'm familiar with describe syntax.
Yeah. So it's a simple describe block and then an it block, and in that it block you're gonna just do a single assertion because we just want to be able to run this and know that we're actually hooked up with RSpec and stuff. Perfect. And then in there, just expect 1 to equal 1 or something. Great.
Okay.
So let's save that and run it from the command line. Actually, you need to use the RSpec program for this. Awesome.
Guys,
okay.
Sorry, is my audio coming through?
Yep, your audio is coming through.
Yeah, great. Thanks. So we're set up?
Yeah, we're good. We're good. Cool. So let's see. So thinking about this test, the first thing is I know that it will. We know that it prints out a particular. It'll print out the order of the mobsters, putting mobster in front of everybody's name. So let's start. So we'll start off by doing that. And this, because we're dealing with legacy code, we're going to write pretty high-level stuff. We're trying to wrap the behavior that's there so that we have a safety net in order to refactor to make it even more modular and more testable. But so at this point, we're actually going to run from within the test. We're going to run the command itself and treat it as kind of an acceptance test in terms of the very high-level behavior here. So, so what I want you to do is let's make a new. Let's clear out this one test that's here, and the test that I want to run is that we will, given a particular mob, given a particular rotation text file, it will print out the order of our mobsters. So we'll call this it prints out the rotation order. One more time so we get this on. Well, we'll be loose on this. Okay, so thinking about how we run this particular thing is that we have a text file, and we have this command, and we pass the text file to our command, and then that prints something out to the screen. So if I want to test this, then that means that we need to set up a rotation file. We need to call the command, and we need to somehow get the output of that command. And I think that the simplest way for us to do that is just go Unixy on this and redirect the output of the command to a file, and then assert the order of the file. So, Ben, I would like you to in the very first line here. Do you know how to run? Do you know how to like execute command line stuff from within Ruby?
I think there's a few ways.
Yeah. So we'll use perfect. We'll use the backticks. Okay. So in this, I want you to echo a name, any name of your choosing, into a rotation test file.
Okay.
Awesome. So echo one. You know what? Yeah, we'll do. I want to make it a little more complex. So add one more line to it, just another name.
Penelope.
Penelope. Penelope.
Penelope.
Just do it as a second command. I see what you were doing.
Well, I was trying to.
Yeah. So Control XU will undo that, and then if you do Control Space, we'll start the selection, and then highlight to the end, and then do Option W. We'll copy. It doesn't copy. Oh, you know what? Here, let me. I know that some people. Oh, sorry, man.
Sorry. Take over.
I took over driving because I'm a jerk.
Hot potato.
Hot potato. All right, so undo a couple times. Try Control XU a couple times to get back to where we were. Okay, great. So I'm going to take over for just a second in order to copy this, because I don't know why it has problems, but it does on some people's keyboards. So let's add one. So just change that name Bob and make sure that is appending to the file as opposed to overwriting it. Phoebe.
Nice.
I'm even more impressed that you know how to spell Phoebe.
Appending. That's right, is it?
Two?
Double, yeah.
Is it double?
Yep.
Okay.
So one redirect symbol will completely overwrite the file, and then two redirect symbols will append to the file. So this is now setting up our rotation order. It's our rotation database. And so now let's run the command, our mob rotation RB file, passing in the test database, and redirect the output of that command to a results.txt file. Okay, perfect.
And redirecting that to output file.
Yeah, it's called results.txt. Okay, so that's our basic setup, and then we need to assert. So let's read the contents of our results file.
In Ruby, right?
Yeah. So in Ruby. So now we're out of the running command line stuff, and now we want to start asserting stuff, and we want to do it in Ruby. So read the file using Ruby, and then we'll start comparing it. And I think let's use read lines so that we're able to split the lines out easily. And store that in a variable. Cool. And then on our next line, let's assert that the output equals chicken. Love chicken. You know, I like chicken because in Ruby, to raise an error message or to raise an assertion, the command is raise. So if I ever need to do something, I raise chickens.
Nice.
I always raise chickens. So expect output to, I think you can't use the double equal on this. So you need to use EQ and then, no, that's great, but wrap that in parentheses.
This?
Yep, exactly. So EQ is a method that returns a matcher that gets passed into the expectation. So, okay, I expect this to fail, and I expect it to show us the output, and that the output is chicken, or that it's not chicken. So let's run this, and we'll see that it should fail. Okay, great. So we see it should expect chicken. It got these other two instead. So now let's compare it to the array Mobster Bob and Mobster Phoebe.
With new lines on the end?
No, because we want to, so we're trying to, I want to test this in the most natural way. So we know that this is going to fail because it has those other new lines, but that means that we'll change our read lines a little bit so that we get this. But what we're trying to do is verify that that when we run this program, we get these two mobsters. Okay, cool. So let's switch back over. And kind of like we did over in the other one, if you want to reject all the lines where L strip, actually, you know what we need to do. So in our output here, we need to map. First of all, we need to map on strip. So in our output line, if you call .map and then pass it let's use the symbol to proc version because it should work. Perfect. And then do a .compact on there.
Wow. Very good. Symbol of proc and it just popped right in your head.
Yep.
Try that?
So, yeah. I actually kind of don't think that'll work, but let's try it. I think that it's going to give us one extra value. Yep. So, so instead of that compact, just reject any where it's empty. And you can use symbol to proc again.
What's symbol to proc? Can you explain that?
Yeah, so when you have a method that requires a block, if you see here in our other window where we call l.strip.empty, that's a block of code that we're passing in. But oftentimes you'll be calling an individual method. So like it would be l.empty, not l.strip. So if it's just an individual method that we're going to be calling, then Ruby provides this mechanism where it converts a symbol into a block that you can pass in. So it's just the ampersand sign converts anything into a block, and it calls this method toProc on it. And so it's just a very simple way of compacting the syntax, making it look a little nicer. So now I expect this one to pass. Okay, great. So now I want to rotate. We got our very first test. So first of all, let's high five. I can't high five you guys, but we can do virtual high fives.
Should we rotate?
Yeah, let's use the thing. Let's use our nifty little program.
My timer's gonna die.
Is it?
Yeah, I mean not my timer, but
So rotate?
Yep. Okay, so it looks like I am now driving, and Robert, you are El Navigatoro.
El Navigador. Okay.
So as part of this, I'm still going to act as role of the customer and kind of define the general requirements. But we're not working on new feature stuff. We do have a very first test, so now it's up to you to. As a customer, I don't have any new requirements and stuff here. So we know that our general task here is to start adding tests and refactor it and get this to a point where we can add new features. So given that knowledge, Robert, what would you like to do as the next step?
I kind of think it would be cool to write a test where we can add the people in without having to write the text file. So I think that could be a good start. Rather than refactoring the stuff we have, or we could do a little refactoring and then jump on to writing the new test. Is that kind of up to you? What do you think?
Well, I don't want to. Maybe I misunderstood, but do you want to add a new feature of setting up the rotation file?
Yeah. So that way you just say like rotation add mob, and then or add just put in a person's name or something. You know?
So I get that, and I will do that at some point. But as the customer, I feel, whoops, as the customer here, I'm a little bit nervous about so much untested code and poorly structured code, and I would prefer for us as a team to get some good solid code in here before we start adding new features.
Well, let's test the rotate function then. We tested that it prints out the whole order, so let's test that it rotates it and changes the order around. So I guess our test is going to be almost the same, except we're going to change where it says Ruby mob rotation test. We're going to say rotate afterwards.
Okay.
And expect that the order on those is going to be reversed.
Okay. So it's this, and we should see.
Well, is it structured? So how do we simulate that the time is up for this?
Well, we don't need to simulate the time's up because so far the program is not doing any sort of automated rotation and stuff. It's simply handling the rotation and telling us when we do need to rotate, right? And yes.
See what we get.
Okay. Oops.
Oh, so it's getting the whole list.
Whoops. There we go.
I got you. So it's printing out the original order, then it's printing out rotate, and then it's printing out the two new.
Yeah. So this is where, as customer, I would be okay with it not printing out the original order and the rotate command.
That's what I was gonna say too. So yeah, let's open up Popek in the code and see what we can do to sort of figure that out, so it doesn't print out the original order.
Okay.
So we have shifts the line if the rotation line is up, and then it puts them in there. So why is it showing the mobsters twice for this? I guess.
Well, I see that we're calling show mobsters here one time.
Oh, so any
we're printing the command, and then we call show mobsters again as part of the rotate method.
I got you. So why did you guys choose to have that show mobster line there instead of just putting it in the methods? Was there any particular reason for that, or it just sort of fell out that way?
This is just what we did yesterday.
So can we drop that show mobsters above the puts there and just see what happens?
This one? You want to kill that?
And see if it's gonna whether that okay, never mind. That's what you're saying.
Well, so now we have some tests.
Yeah, so it's
one line. We can always run the test, and we can always undo.
Yeah.
So one thing to understand when we're doing this stuff, we don't always have to know what's going to happen. We want to have a rough idea. I always try to predict what's going to happen, but if my predictions are wrong, that's okay, and that gives me a little bit of feedback to make a better prediction next time. Okay. So with this, my prediction is that both tests will fail.
Yeah.
And the first test will fail because it's no longer printing out the order of the mobsters, and the second test will fail because it still has an extraneous command in there.
Yeah, it's still missing the rotate, yeah.
So let's see. And they both fail because in one we didn't get any output, and then in the other one, so my predictions are
correct.
Spot on. I'm a regular Nostradamus. So what do we want to do to get these puppies passing?
I'm thinking that we should change our... I kind of feel like changing the original test, so it says Ruby mob rotation, where the default command isn't to just print out the list. You know what I mean? So,
I don't want to change the test. I really like the tests the way that they are, and that gives us the safety net that we need to start changing this. And I don't want to change the functionality too much. I think that the feature that was there right now of rotating it prints out more stuff than it needs to. But I like the default of printing stuff out. And so I think in this case, like, my next step. I just want to get these next two steps passing, these two tests passing, and then we have a safety net. We can start making more changes.
Yeah. So put that back in so we pass the first one, the show mobsters. I'm wondering if we drop it from the rotate command, whether it'll do the rotation and do the original one that we have up higher.
Okay, so is this good?
Yeah, try it.
All right, so our first one's still passing. Our second one looks like stuff is out of order and it has this extraneous rotate command.
Yeah. Okay, cool. So let's pop in and then see why we're why we have that rotate in. I guess I don't. Each. Yeah. Where is it putting in the rotate in the array? Okay, there we go. So drop that. See what happens. I think it'll work. Okay.
Close, but we're out of order still.
Okay. So, because it's only printing out the original one.
Yep.
Yeah. What if you put that at the bottom of the file?
What if, indeed? And boom goes the dynamite.
I was thinking it was that. I wasn't sure. Yeah, that was my original guess. So
cool. So look at that. We cleaned up some. We got a few lines less code. We got test passing. There's only two features to this program right now, which is printing out the rotation and actually handling the rotation. So now, in this case, we have as customer, I feel good at least about having test coverage. So now it's up to you to kind of figure out the next steps. We can start to refactor this a little bit. We can add new features. We can change the interface so that it doesn't take the test file or the text database. Whatever you want to do as a next step.
So can I interject something?
What's that?
Can I interject something?
Please.
So one of the first things you had talked about earlier was encapsulating the global variables. So it may be a good time to refactor and get things a little cleaned up, because right now your code maybe is not as clean as you'd like it to be.
I agree 100%. So as yeah. I think that is a very desirable next step. It's time to switch already?
Yep.
Dang, okay. So let's do our rotate. Time to rotate. Robert, you are driving, and Lucci, you are navigating.
Awesome.
All right, cool.
What's the command to switch the Remux window really quick? I don't remember it.
Control B, and then let go, and then N.
Okay, cool.
Why is Woody suddenly a banjo player?
All right. So I guess what about the first step? We just knock off all those dollar signs.
Okay.
There's also some dollar signs in between the sentence.
Oh, these ones over here, right?
Uh-huh.
You see any more? Oh,
Yeah,
where?
Yeah, in the rotate method. And yeah, here.
Oh, and there's one more right there in the rotate.
Oh, good catch.
How's that?
Okay, let's actually run a test and see what happens.
Okay, cool. It was rotation. No, rotation.
Nope. We need the RB file.
You can just up arrow on that one if you want.
There it is.
Mob rotation spec. Yeah, that's it.
Cool.
Cool. So we now done the first step. Can I go back? All right, let's see. I'm not quite sure what to do now, actually. So, let's see. Pat, as a customer, do you have any more features you want right now?
Well, so in terms of this session, I would really like to use this as a chance to start wrapping this in tests and refactoring and clean up the code. We have these high-level acceptance tests. What would make me really pleased is if our code was clean and unit testable, because it's currently not unit testable at all. So we have these high-level tests, but I want to be able to have unit tests in there, so kind of more focused tests. So if once we get to that point, we can start adding new features, but I don't think we're there today.
All right. So what about we just encapsulate all those things into one class?
Can I make one suggestion?
Uh-huh.
Do we know that the code still works?
Yeah, they just ran the test.
Yeah,
We just ran the test. Okay, cool.
Uh-huh, yeah. All right, so Robert, let's make it a class.
Below the require, right?
Uh-huh. Let's call it mob rotation.
They didn't save it.
Oh, they did.
I got to interject one thing. Did you save the test? Did you save the file and run the test?
No, I didn't. Wait.
Oh, okay.
So when we're doing refactoring, we're making changes. We're going to run the test very, very often after the very smallest change. So we take those dollar signs out. That changed our global variables to local variables. That's a significant enough change that we could have broken something. So we want to run the test and make sure that we haven't broken anything before we take the next step. Because if we start wrapping stuff in classes, one, we may be doing work when stuff is broken, and so it's going to be waste in the first place. And two, if we then run the test and it's broken, we have no idea really which one of those steps broke it. It could have been the global variables. It could have been the class. It could have been, you know, whatever was in between. So we're gonna run our tests after every tiny little change to get some feedback.
Save, that's why.
They ran it, but they didn't save it.
Yeah, so just very important to make sure that you save the file before you run the test.
Okay, let's see the error message. It's actually undefined local variable for start time. But for right now, for all the features we have, I don't actually see we need this variable. So one way we should do it is we just comment out all those code related to like start time and all those methods, and we can do it again.
Okay. And it was the start time.
It was. Yep.
Is that it?
Uh-huh.
Sorry, John.
All right, let's save it and run the test again. All right, different error message. Rotation time. Okay, let's go back and see.
No, it's all on the code.
Can you go back again? Let me see which line is producing the error message. Alright, it's actually 32. Can you go back to the file?
Okay, what do you think? Smiling all the time.
Yeah.
I'll say
Well, is this not?
Is that the
32?
Right.
Okay. What about we just comment out this line, because we're not actually using this feature now. Alright, save it and we just run it again. Alright, so we got one test pass, which sounds good. Okay, let's read the error message again. It's undefined local variable method rotation time. Still at line 32. Okay, Robert, can you go back? Where's line? Okay. Okay, so now we've reached a point where we cannot rotate the line because we need this feature. So let's see which thing is missing. So it's actually missing the variable rotation time in the rotate method, if I understand it correct. So the so I guess that is why we have all those dollar sign in front of all those variables at the first place. But now, if we're going back to the global variable, I don't think it's a good idea. So, can we just start maybe add something to actually capture this variable in a class, or we have to try to pass it in some way?
Well, so okay, so those are both really good options. One would be to start wrapping this in a class. One would be to pass it in. I would say that if we want to go start moving to a class, we don't actually have to make a class yet. There's something that we can do that takes us one step closer to being a class. That would make it easier to then start wrap it in a class. So imagine when we're dealing with some code like this, imagine the class that wraps it. Imagine that this is inside of a class, and we just haven't yet defined the class. So if this were in a class, how would you access that rotation time variable?
We'll basically store it in an instant variable.
So would that work for this? Do you think that would work here?
No, not really. We'll need actually maybe a class variable, or I guess I'm not quite sure now.
Okay, so then you mentioned another approach to fixing this, to fixing that rotation time problem.
You may actually pass the rotation time variable in. Okay. All right, let's go ahead. Robert, can you go to the rotate method definition and passing a the method signature. Yeah, we add another variable called rotation time. Okay, so we call it at the second last line, so we need to add a passing an actual argument for rotate method. I mean here. That's passing rotation time. All right, let's save the file and run it again.
So we're gonna
It's missing the file name now.
Huh. Oh. All right, let's go back and see where it is, where the error message is coming. All right, so that means we also need a file name variable. So let's do that also, passing another file name variable. And also, yeah, go to the second last line and
Gotcha.
yeah, add that variable and see what happens.
Awesome.
All right.
Nice.
Cool.
Nice.
So that was fantastic, Lucci. So it's time to rotate. So Rob, can you run the rotation command? Awesome. So I'm just going to point something out here, kind of about high-level tests and low-level tests, and that we kind of got lucky here, in that we actually got error messages when we ran when something failed, and that is because if you notice in our test we're redirecting the output of the command to a particular file, but the error messages that we're seeing on screen, those are not coming from the test. Those are coming from the program that's being run, and it just happened that it's printing error messages to the standard error output as opposed to the standard output. And so that's why we see it on screen, because it's printing out the standard error, and so we're seeing it printed to our normal standard error. But if we were to, let's say that Ruby did not print error messages as standard error and that it printed them to standard out instead, then it would be rewriting it to that file. So this is where we get into to defect isolation and good feedback from tests. By having fine-grained focused tests, we get error messages that tell us immediately what's broken and exactly what's broken, and it's not at a very high level. So we kind of got lucky here in how Ruby is printing out the error messages, and it would have been trickier if we didn't see that and stuff. So that demonstrates kind of why we want to have, at least one of the reasons why we want to have smaller, more fine-grained tests in the first place. So we rotated. So Lucci, you are driving, and Nathan, you are navigating.
Righto. Am I coming through, guys?
Yeah.
Yep.
Hi.
Awesome. Okay. So let's go back to code. And we'll pop it in the class.
So what? Coming again?
Yeah, so just go up to the top and...
Oh my gosh, guys, can I interject something? Can we commit?
Oh,
Now
yeah.
we have passing tests and refactored code. Let's commit.
Do we need a test and result text file?
You know, I think maybe not.
All right, so okay. Oops, I'm not sure if I
think just hit Y.
Yeah.
hit
So
Y.
Hit enter, and that'll save the commit message. Cool.
All right.
Okay.
All right, let's go back.
All right. So let's create a class.
Sure.
So we'll call it mob rotator.
Looks good.
Okay, so we want to we want to be able to unit test stuff, right? So would it make sense to wrap all of that inside the class to begin with, or that's not going to work syntax-wise, is it? No. So let's move our rotate. Let's move our methods inside there, the ones that we defined already.
Uh-huh. So
Lucci, I'll take control for a second just to get the highlight going, because I know there's whatever weird stuff with it. So now, if you control W, that'll cut, and then wherever you want to place it, when you hit control Y, that'll yank it back out. And I'm going to show you a nifty little trick. So let me take the keyboard a sec real quick to get the highlight going. Now, if you do Control X and then let go, and then type R and then let go, and then T. Now this is doing like this rectangular editing. So if you type 2 spaces and hit enter, it's going to put 2 spaces in front of every single line, and that's how we got nice formatting quickly.
cool.
Carry on, Nate.
Yeah. Okay. So I'm just trying to figure out how this is going to be called from the spec. So Okay, so the function names, we'll probably have to change the method names because we're going to be passing in a command. So we're still going to be calling this from the command line, Pat, or is this?
Yeah, well, so I mean, now it looks we're refactoring, right? So we have test coverage in place.
Yeah.
We can make any changes. We can run the test and see if we've broken anything.
Right.
But we're not writing new tests. We're not trying to unit test this yet because the code's not very unit testable. So we're refactoring it to make it more unit testable.
Gucci. So it's not a good time.
Gotcha. Well, I mean, our integration tests aren't going to work yet anyway. The tests we've written already. So yeah, we need to create an instance of mob rotator after the class definition.
Sure. You mean here, mob
No,
rotator?
outside the class.
Oh yeah,
So,
I see.
And yep, let's call rotate.
Oops.
Okay, and we'll need to move. We'll need to instantiate. Let's instantiate mob rotator to accept the file name as to its constructor.
So what arguments are you gonna take for this?
Yeah, okay. Let's just take an argument called mob file name.
Okay.
Let's make that lines equals file.readlines up into the constructor. So down further, we've got lines equals file.readlines.
So where is it?
Below the file name, the argv commands. That line, can we move that? Oh no, leave those there. But the lines equals file.readlines. No.
So we want to create initial.
No. Let's go down 3 more lines. Let's cut that line and put it inside the constructor.
So Lucci, Control K will delete to the end of the line and put it in the buffer. And Control Y yanks it.
And let's just store lines as an instance variable.
Sure.
So put an @ sign in front of lines.
Looks good.
And then we could change our method signature of rotate. We could remove lines out of there.
Oops.
Control X U.
And yeah, put an & in front of both of those lines. And again. And then also in show mobsters, we need to put an & there in front of lines. And remove lines from up 4 lines, 5 lines.
Oh, I see.
And then remove lines from the method signature of show mobsters.
Okay.
Let's run our tests and see what's happening.
Yeah, what's the shortcut for save the file?
Hang on a second. Look at the bottom of the code window, it's showing us the status It shows UU star star F1 mob rotation.rb. That star star means that the file has been edited and has not been saved since it was last edited. Meaning that if we were to run the test, we'd be running the test against a file that has not been saved.
Right. So let's save the file. That's Control X, Control S. Oh, you did that. All right. So we didn't initialize with the. Let's go back to the code, and when we initialize, yep, let's put the file name in there. Well, we're passing from the command line, so we could let's just put file name there instead.
Oh, I see. Yeah. I see.
We'll give them a little more time.
Let's save that and run the tests. Okay, let's go back to the code. We go to line 5. Oh, okay, right. So we need to change, go up one line and change that to mob file name.
Here.
Actually, let's store mob file name as a as an instance variable. And also go back up to line 5. No, back up to line 5, where it says file.readlines, and change that to mob file name.
Oh, sorry.
And then on the line above as well. Okay, then in the rotate method signature, you can remove file name from there. And move down 3 lines and change that to mob file name with an @ sign. Okay, let's save that and see what happens. And run the test again. Okay, just jump back to the code. Line 38. Okay, so you can remove, yeah. So we're just calling, just go back down to line 38, please. And just pass rotation time to the rotate method. And on the line below, remove lines. Save that and run the tests.
Yes.
Nice.
Okay.
I love
nice.
it. So it's time to rotate. That was awesome. We refactored into a little class. Nathan, I'm just going to point something out. If I were navigating there, I would have run the test about a dozen times.
Right.
In the whole time that we're doing that. Really, after like every small little change, I want to make sure that we're still going. Now, you pulled it off, and there were a lot of steps there. To me, that feels like working way harder than you have to. Like thinking way too much, because I can make one little change, run the test, see if it still works. One little change, run the test, see if it still works. Fine. Just an observation. We have the test coverage, so I would use it. But let's rotate.
Sure. Appreciate it. Thanks.
How's everybody doing on time? Because we're at about an hour here. I want to make sure that everybody gets a chance. Jen and I are fine to hang out and keep working for a while. You guys still good?
Yeah, I'm okay to hang around.
Good.
All right. Yeah, I guess you guys are all adults. Whenever you need to take off, take off. So yeah, let's rotate.
We run the rotation.
Okay, so in theory this should work, right? I just ran the.
What did you run?
I ran the Git app. It's 5 in the morning.
Oh dang! Oh dang! Sorry, dude.
Right.
Awesome.
Hey,
So Nathan, you're driving. This is Diamond. You're navigating.
Okay, so let's go back to the code.
Control X, Control B, N.
Control B, N.
Yeah.
Scroll up to the top. Oh, actually, right away, can you change the bottom to where the start time is the file name to mob? Didn't you change that to mob file name? Isn't that mob file name now?
Well, the tests are passing. The code works.
The tests are passing.
The tests are passing. All the code works.
Okay. All right. Then let's put the last. Can we scroll up to the top so I can see the top?
Yep.
Should we put the last rotation time? I mean, oh no, we're not even the last rotation into.
So let me point something out here. I think that now that we've wrapped this in a class, I think it's unit testable because we can instantiate something, we can call methods on it, and so that gives us much better access to the functionality than it was before with all the global variables and this kind of a batch script stuff. So I think a really good next approach would be to start getting more fine-grained tests, focusing on the individual aspects of the behavior as another layer of test coverage in addition to these high-level acceptance style tests that we have.
Okay, I'm not sure how to do that. So we would go to this same test file?
Yeah, we can just keep everything in the same test file.
Okay, so
what
do we want to test for?
So to switch over, you do Control X O.
Okay.
Okay, and are we going to create another test, another describe block, and another if block?
Yeah, we can do that. So let's start off. Let's unit test the show mobsters method.
Unit test the show mobsters method. Okay. So what does the show mobsters method do? It puts it iterates through the text file and puts all the mobsters, concatenates the mobster with the person. So let's see. So I guess it prints out all the mobsters in the text file. Let's see. So the output should equal the all the mobsters in the text file.
Okay.
So create the.
So let's think of like how the test structure. You remember arrange, act, assert?
Arrange or act, assert.
Arrange
okay.
being like our setting up the state of the world before we do anything. Act then is whatever action that we're trying to take that changes the state of the world. And then our assert step, we verify that the new state of the world is what we expect.
Okay. So arrange would be what exactly? I know the part of we like expect something to equal.
You can put it in your
Okay. Expect it to equal.
Well, is expect part of the arrange, the act, or the assert?
That would be the assert.
Okay.
Right?
So you can totally, one thing I like to do is starting with the assert and kind of build up from there. So if you want to, so that's a good approach.
Okay, so can you write the assertion of what we want, which would be we expect output to equal the names in the text file?
Okay. Which will be.
I don't know how to do those two things.
We'll get there.
Okay.
So what do we want that to? What should it be equal to, Jen?
It should be equal to the mob file name, right? Just show mobsters plus the well, it should be equal to the mobster plus person the mobs all the people in the file name with mobster concatenated to it.
Okay, so we're just going to use our test file again.
So what are the actual values that go in here? Like what's a string that we could put in?
Could be the string mobster plus plus mob file name. Is that possible? Like, can you concatenate in the
Well,
an argument?
we're trying to write the assertion here, so we want it to be very clear and explicit, and ideally just compare it against a basic string.
Okay. So.
Because it's printing out.
So
strings to the screen.
when you print out, I mean, when you call show mobsters, it should just print it out, right? So can you call just show mobster?
Okay, so we need.
So this is actually so Jen is kind of is moving to the act part because we're kind of not quite sure what the assertion is going to be yet. So I think that's fine. So now we call the show mobsters method like you said.
Oh. Okay.
And then now that forces us to figure out what's the arrange part and what's the assertion part because we'll have the act part sorted out.
Okay.
Okay.
Mob rotator. Not show mobster? Oh wait, oh I get you. Okay, I see what you're doing. No. And then act.
So the show mobsters is our act. The mob rotator equals mob rotator.new is part of the arrange. We're setting up the world, which is we need an object. And then we're going to do something that triggers a change in the world, and that's our act, which is our show mobsters. In fact, Nathan, could you put comments in the test to clearly show the arrange, act, assert sections here?
Sure.
Nice. Okay, and we want it to equal what it prints out, right? So if we're calling what that prints out is show mobsters, so it should equal mobster.
I have a feeling I understand why you're struggling with this a little bit, Jen. Because in a test, we have ultimate control. That can be literally whatever we want it to be. So there's currently if you think of the test, we arrange and then act and assert. So we need to set up some initial state, we need to do something, and then we need to verify the end state. So that means that we need to define what the initial state is, and we need to define what the end state is. Without us defining it, it doesn't happen automatically. So you need to make a choice about the setup and the assertion.
Okay. Okay. I'm not sure quite what that means.
So what does the show mobsters method do?
It prints out. It iterates through the text file. It opens the text file. It grabs the mob file name, opens it up, and concatenates the word mobster in front of each person's name and prints it out.
Cool. So what is currently missing from this test?
A puts. A puts.
All right. Let's rotate. So Nathan, if you could switch back over and run the rotation commands. Cool. So Jen, you're going to be driving. And Woody, you down to navigate?
Sounds good to me.
Awesome. Okay.
So let's go back to our tests.
Okay.
Control B, N.
Control B, N.
Alrighty. So first of all, in this model that we have right now, I assume in Ruby that if we have an initializer, we must use the initializer as declared. Am I correct on that?
Yes.
That means we would have to pass in a file. So, you know, we could call that file foo right here for the moment, because that's a kind of a standard name for this. But I now have a question. Is this standard in these sorts of tests? Would we want to create a file that we would use in a test and then pass it in? Is that how this works?
Yeah. Well, so this is kind of interesting because we're still printing stuff out to the screen, which means the only way for us to verify it with the code structure that we have right now is to do what we're doing in the test before and redirect some output to a file and verify the file. So the style of the test is fairly similar to what was before, only this time we're calling the specific method on the object as opposed to running it directly from the command line. But given the structure that we have, I think we still need to set up an initial test file like we've done before, and then we need to read the output and verify that.
Okay, so that means we have to redirect the output to a file?
Yeah, we need to.
Okay, and so that means in our act, part of our act is going to be to, let me see where we get to do that. The output equals the file read lines up above. I'm just looking at the, I don't see any line numbers here, so can you turn line numbers on in this editor?
Unfortunately, no, not with how it's set up right now.
Okay,
The best
just wait a minute. I'm going to draw the line numbers on my screen.
There are some work down the bottom that says L25.
Yeah, the best reference that we have is down at the bottom of the screen. It tells us the line number we're on.
That's okay. Yeah, I noticed that one. Alrighty, so yeah, since I don't really know this environment very well, we need to be able to redirect our output from, let's see, from our call to show mobsters.
Yeah, and so so now this is interesting because we have, before we were running it from the command line where we can do the Unix redirect to standard out. But now we're actually calling the methods directly. So when we puts, we can't, I don't think that we can actually easily redirect that out the same way that we've been doing before. However, does anybody remember from the very first, I think it's the very first lesson, how we can redirect standard out from inside of a Ruby program?
std out.
Yeah, so what happens when we call puts? Where is that? Like, that's going to a particular object in Ruby.
Yeah. Well, it's creating.
What object is that? Does anybody know the object that gets called when we
String
call puts?
object? Oh, string.
It's a global.
Put S, right? Sorry.
It's a global variable.
It's kernel, right? It's a kernel. Well, it's a kernel method, and it's.
Have any of you guys done lesson 1 out of curiosity?
Global STD
I
out.
looked at lesson 1.
It's the very first lesson.
Let's look at it.
So it's a global variable called std out, meaning standard out. And so by default, that prints it out to the standard out on screen. But in Ruby, we can redirect our standard out by simply reassigning the standard out global variable. So now all calls to puts
inside of our test?
What's that, Liddy?
Can we do that inside of our test?
Yep.
Okay, so let's go ahead and so if we were to do that, we're going to pass in a file name in foo. So we need to make the file first, and then at what point would it be in our range? The second line of our range would be the so we'd have to add a new line in above the line that you currently are working on.
Because we need to reset the standard out object before we call show mobsters, right? Because that's
right. So right here is where we would do that, right?
$ standard out lowercase.
Oh, really? No. And what are we putting in there? The mod file name?
Well, so I would actually just make this a new object because we're making an assumption here that if we reassign standard out, that our calls to puts will go there instead. Now, I'd like to verify that. So a simple way would be to make this a new object and run our tests. And what we should get is an error that we're trying to call this method on an object that doesn't have it.
Okay. What are we making an object?
How do we make a new object?
Oh, okay. A new object of a new class or
How do we make a new object?
So do we need a new line for this?
a new line?
Well, we're trying to assign something to the standard out.
So do we instantiate that class on the line with standard out, or do we instantiate that in the line before?
We can instantiate it on this line because we're just trying to assign it to this.
So how do you do that? With a new?
In Ruby, the syntax is classname.new.
Okay.
Alrighty.
Oh, okay.
So
Okay.
we already get his foo, so let's use bar.new.
I would suggest just making a new object. Just
a new rotator object?
No, a new object.
Just the word object. So object is just a generic object?
Yep. It's the base class. So there's a class called object, and we want to get an instance of it.
Okay. Oh, object on it?
Yep.
Oh, okay. Oops.
Object. That's what happens when Obi-Wan Kenobi gets blasted out of a plane.
Okay, so then we'll need the file. So right now we've set the standard out. We call the show mobsters. We should be able then to read from object new somehow on our assert. Is that where we're headed, Pat?
Yeah. So I actually at this point, because I want to make sure that this assumption is right, that if we do this, that we're actually calling the method, we're calling something on the object that we're passing in. So I'm not really interested in making this test pass yet because it's kind of tricky given the structure that we have. So we're just first of all trying to validate the assumption that we're making here about reassigning standard out as part of a Ruby program.
Okay.
Right. Okay.
On the test.
So we should be able to somehow look at object new at some point and see what it gives us.
Well, so I would expect that if this doesn't know how to print stuff, then by calling puts on it, it will actually give us it'll raise an error, is what I would think. So
okay, so if we just run it here, we'll see that error.
What's on it?
Let's go ahead and run this test.
Okay.
Mm-hmm.
Do I hit return?
The file saved.
Oh, okay. Control B N. Okay. Turns on what's in the text file.
So the first thing here is, of course, we got this foo. It doesn't know about that. Is that correct?
We didn't actually get that far. it barfed on mob rotator.
Yeah, where it says foo.
Yeah, so if we look, name error, uninitialized constant mob rotator. So this is kind of interesting property of Ruby. Ruby has not evaluated foo at that point. It's looking at mob rotator, and it fails before it even gets to foo because it doesn't know about the mob rotator class.
So
Okay, so we all right.
New before you say mob rotator.
So does anybody know why it doesn't know about the mob rotator class?
Just need to require the class.
Yep.
What?
We just need to require the class inside the spec at the top.
Oh, very cool. Smooth. Do I have to do insert or anything? Just require?
No, this is a real text editor. You don't need to tell it when you want to type.
Why didn't the earlier tests require that we do this require?
Because there was no class before? Oh no, there was a class.
No, so in the test before, we're running from the command line. That backtick means to evaluate some code, some command line code.
Oh, okay.
We haven't referenced any, prior to that we had not referenced the Ruby object mob rotator. And in this particular test, now we're referencing mob rotator as an individual class. So
okay.
Ruby needs to know about it.
Okay. Should we try to run it again? Woody's navigating
Yeah,
stuff.
go ahead, run the test.
Okay. What?
Cannot load such file, mob rotator.
Wow.
Is there a file called mob rotator?
I don't know what is our file called.
What's our file called, Jen?
The mob. I don't know off the top of my head.
So how can we see?
Can we tell from the file?
Hmm? What?
Can we look at the file itself and tell from the file what it's called?
Mob file name.
It's called mobrotation.rb. Is that right?
Oh,
yep,
yeah,
that's right.
So instead of requiring. So where do we put that?
So our require is incorrect because it's trying to require a file that does not exist.
So we need to go up and change that to the file name.
The file name, not the class name. Oh, mob. What's it called?
Well, it's there down there, mob_rotation.rb.
And you don't need the .rb when we're doing a require.
Oh, you don't need the .rb.
Correct.
Okay.
Yep, sorry about that. Alrighty, run it again.
Okay.
Okay, that barf, but I'm gonna take over real quick and show you guys why. It's because Ruby, when you require something, you need to have the load path set right. So this doesn't make any sense probably, but $: is the global variable in Ruby that means load path, and unshift is a method which puts so this is an array, and this, I guess, prepends it to the array. So whatever we put here now becomes the very first thing in the array. So if we want to require something that's in the directory that we're in, then we need to add the current directory to our load path so that when we require the file, it knows how to find it. And there we
Excellent.
Go.
But could we just use require relative instead of this first line?
We what?
Could we just use require relative instead of unshifting? Yeah, this way.
We totally can, and I learned something new today. Thank you.
What's require relative?
So require relative is
in Ruby 2.0.
Yeah, because you didn't need to do that unshift stuff before in Ruby 1.9, so that makes sense. So, but require relative is just relative to this particular directory, or I guess this file.
Our file is in the same directory as the other file.
Yep.
Okay, so run our test.
Okay. BN.
I don't think it's saved.
Okay. BN. Oops. How do I get back? Oh, Control B and. Yeah. So, X, Control S. Saved?
Saved.
Okay. Control B. N.
Do a clear so that we can kind of see what's going on.
I don't know how you clear. So you just clear. Okay. Oops. Okay. So it did print that stuff out.
Okay, so the local variable name or method foo is undefined, so now we need to, I just put that in as a placeholder for a file name. So I suppose we now need to make that a reality.
Okay.
Let's go back to our tests. And we need to declare, I suppose, a file name, put some stuff into it, save it. This seems a little awkward to me, but save it. And then, no, you can leave it as foo right now.
Okay. So
On the line above, I assume we just want to, we need to make a file and save it, right?
Well, so our rotator class takes a file name. It doesn't take a file object. It takes a name.
I understand that, but we have to save a file with some data in it.
Yeah, we do.
That's all I'm saying. Is we need to create a file. Our test, I'm saying, I mean, I don't know, that our test needs to have a file to work with. We could just use a file that is always there, or we could create it here and pass that file in.
I would. So we could let's do it in Ruby just so that we get kind of a different approach here. So I'll kind of help navigate this stuff. So Jen, on the line above this, do file.open.
a new one.
Yep. Capital F because we're using a class.
Okay.
And pass it a file name for something that we want to use.
Like the mob file name. I mean
well, no, we need a string. So it's a file name.
Oh, okay.
And actually, because we're using the variable foo to represent the file name, then we could probably use foo here.
Okay.
Let's use the variable foo because we want that to be the same.
Okay.
Whatever our file name is, we're assigning it to this local
so
variable.
Foo equals foo? No.
Well, let's make this pass in the variable foo. Not a
Get rid of the quote marks. Get rid of the quote marks.
Oh, okay.
So if we want to write to it, it takes a second argument, which is the string w. And then now it yields a block, and that block is a file. So just like that, basically.
Oh, okay.
So we want to use do, and it passes a file object. Yep. So get rid of that dot in our W.
Oh.
And so now in our block, we want to append stuff to this file.
Oops.
So just like we do here with file, appending to an array, kind of.
Lines each?
We're not going to do lines each, so we're just writing to the file. So if you do file and then the double less than sign. No, in this case we're using
we're using that file.
Yields a block variable.
And appending foo.
What do you want to write to the file, Woody?
Well, let's just go ahead for the moment and put in Bob and Phoebe like we did above.
Okay. Oops.
Now we want to have it as two separate lines or something, right?
Yep.
So I don't know. Do you put that in there as a?
Can we append?
Yep, exactly, Jen. You're right. That's perfect. Okay. So now we got to close that block.
Okay.
Okay. So let's go up to line just above the file open. So that's about 3 lines up, and let's give a name to this file. So we need a new line.
Okay.
Control E will move to the end.
Control E. There.
And hit enter. Get a new line. Then we need to declare foo and give it a name. Give it a file name.
Can we give it the mob rotation file name, or a different file name?
You want to give it its own name. Test. Well, I don't know what this test name is, but we should come up with a name for the test. Let's just call it test for now.
Okay. Test mobsters.
txt.txt. Do you need that? Yeah, that's fine.
We don't need it, but it helps just to demonstrate that it's a text file.
Does it need to be? Oh, text, not test. As text, okay.
No, you're fine. No, you're fine. You're fine. Go ahead and do a dot. Well, all right.
We want to have a file extension there, .txt.
Yeah, we're trying to do an
Gotcha.
txt.
Yes.
We'll get better names in a minute for all this. Okay? That's fine. And so now we've got a name for the file. We open it. We put some data in it. Do we need to close it?
No, because so this block syntax, this is one of the nifty little things about Ruby, is this is using a pattern called, now I can't remember it, but it comes from the Smalltalk best practice patterns. But the idea is that the file open method handles everything that we care about opening a file.
Right.
So it opens it, and then at the end of the block, it automatically closes it.
Very good.
In between, we do whatever we want.
Okay, so let's go ahead and run our test.
Okay. I have to.
Got to save the file first.
Did I do it? Did I not do that?
So if it has 2 stars there, that means it's edited. So if you don't see the 2 stars there, that means it's saved.
So you've already saved
Did
it.
I save it? Okay. I saved it.
So let's go ahead and run the test. Now we'll get finally probably to our object problem.
Awesome. Awesome.
So that validated what we were thinking before, is that when we reassign an object, yeah, so we're able to reassign it to standard out.
So it's telling us we need to have a write method. So let's go ahead and do we need to create an object for this?
I have to go. I have to leave because my car is under a meter for 2 hours and it's about to expire.
Thanks, Jen.
I'm expiring.
See ya.
That's
Bye.
excellent. Will. That's a good way to control the amount of work you're going to do.
Bye, bye, everyone.
It was a pleasure.
Bye-bye.
Yeah.
So yeah, what we found out is that the object doesn't respond to the necessary methods that it needs. So we need a different kind of object that responds to the right
Unfortunately,
method.
you have to go as well, Pat.
What's that?
Let's
I
go.
said I'm going to have to go as well.
You got to go. Okay, cool.
Yep. I did not park in a 2-hour meter, but I do have to go.
Awesome. Well, thank you so much, Woody, for joining us. It's been great.
Yeah, I loved it. I loved it. Now I know how to program in Ruby.
So I have a question. Are you still able to do something in 40 minutes with us, like the chat?
Yeah, let's do that.
Okay, great. All right, cool. We'll see you then.
Excellent. Thank you so much for having me.
Thanks a lot, Woody. See ya.
All right.
Thanks, Woody.
Bye-bye.
Bye, everybody.
See ya.
So let's see, guys. Let's keep going a little bit because I want to get this one test passing, and then I think we'll be ready to go. So I'm gonna take over real quick, and we'll just do a rotate. And I think that basically
I think we need to remove mobsters method now.
we need. Yeah, exactly. So I'm going to. It's our rotation text file. We'll revert this and take Woody and Jen out. Jen, everything okay? All right. Okay, cool. So we are rotated. So Lucas, you're going to drive, and Ben, you're going to navigate.
All right.
Okay. What did we get to?
So what we got to was we have on this particular line, we're reassigning standard out to a different object. And when we ran it, we got this error message that the object that we have needs to respond to this write method. And it doesn't.
Interesting. Is there not a way to do this with RSpec natively, just to kind of stub an object that responds?
We absolutely could. We could use mocks here. So let's try 2 approaches, but let's start off with creating our own class that responds to write. And so this is a fake object or a test double of some sort, but we're not using the actual RSpec mocking framework for this. But this will allow us to very easily be able to collect the messages that are being sent and then verify it. So instead of where we're doing object new, we want our own class, an object of our own class that responds to the write method.
Before we move to the, can I ask how to change the content of the level buffer to see the code again?
Oh yeah, sorry. So hit Control XO to switch to the other buffer,
Control XO.
and then Control XB will ask about the buffer list. B as in Bravo.
1 second. Control X, B.
Yep, and hit Enter, because that's
Okay.
defaulting to the next one. So now that's where we have the code.
Cool.
So,
All right.
so instead of object, Ben, we want to create a new class that responds to the right method.
Okay. Should we put it in the test file just for now?
Yeah, I'd put it in the test file since it's not part of the production code. It's just helping us test.
Okay, so just above the describe block here, let's make a class and just what is it doing? It's just mimicking an output, is it? Or
How do you like to be called?
just call it output, and we'll just give it one method. What was it called? Write. And then just replace the object new with output new in the test. Excellent. Save and run the test.
Control X, Control S, and then
Control B.
Control B N. Okay. Wrong number of arguments.
Okay, so we need to accept an argument, which is going to be something to write. So.
Control BN.
Oh, sorry.
Yeah, so there's two programs that we're using here right now. We're using Emacs as the text editor, and we're using Tmux as the shell sharer kind of thing. So a certain set of commands to switch between buffers in Emacs and a different command to handle Tmux.
So I assume Control X is for Tmux and Control V. Control X is for Emacs and Control V for Tmux.
Basically, yeah.
Okay. Cool.
So let's just provide an argument. Yeah, and then we can run the test again.
It's a similar error message, but it's different. It's not. We did get past the error message from before. It just happens that we have a same kind of error message, but it's on a different line.
Yeah, let's head back to line 40. Test. So we have to, yeah. So we need to expect it to equal something. So at this point, can we just have the string mobster Bob new line mobster Phoebe?
Can you say again?
So yeah, just have the string mobster Bob
mobster
/n mobster Phoebe. Yeah, I don't think we need a space between the new line.
Sure.
Okay. Okay. Save and run.
Awesome.
What's going on there?
So it's not actually, you know, I think let's change that local variable name from output to something else.
You think that's the problem?
Well, because look, because we're saying
it's not
output
actually
is
anything
local
now.
variable output. It's not anything. It just so happens that RSpec has a thing called output.
Yeah, and we're not acting on anything, are we?
So here's what I would suggest, because we're using this output to mimic the interface of standard out, but it doesn't have to behave like standard out. So we just want to verify, like we have this output object. When we call write, we can change the state of that object, and then we can expect based on the state afterwards. Does that make sense?
Yeah. So what do we want instead of the output here? We want our output object that we've made, right?
Yeah, I would think a really simple thing that we could do here is have that write method append to an array, and then we can verify that the array matches what we expect. See how that, because if we add something to an array as part of write, then we know that when, like, let's say that we verify that the array is equal to Mobster Bob and Mobster Phoebe, and we know that everything works because we're calling write in the correct order and we're adding it. So this is just a very simple way of keeping track of the write methods that get called to this.
Okay, so in our write method, let's add the argument to an array.
You mean the write method?
Yeah.
Can you say again? What would you like me to do?
Just that argument in an array.
Which array?
Just create one.
Oh, okay. Something like this?
Mm-hmm.
Okay.
And I'm still not sure what we're going to pass in for the expect method.
Well, we need something. So that method output that we see is an RSpec thing. It's returning something. So that's not what we want.
Do we want standard out or?
Well, okay. Here's what I would suggest. We're assigning this output object to standard out, but we still want a reference to it. So you could actually do standard out in there, but I would make this a little bit more clear and say output equals output.new, standard out equals output.
Okay.
Well, yeah, definitely do it in line. I love that.
So.
And then you misspelled output, I think. Above.
Oh, sorry. All right. Do you want to run it, the test?
Yeah, I'm expecting it to fail, but we can run it. So it's returning the output object instead.
Maybe expect output dot mobster or access that mobsters variable in there.
Yeah, that's a good idea. So.
But mobster are a local variable, so we have to somehow.
We can make it an instance variable, I think, and. Yeah, and then would we need a reader? Yeah. Great.
Yeah.
And then we can just do expect output dot mobsters. Okay, let's run that.
Oops.
Interesting. Okay. So why is that failing?
Well, what's happening in the
Putting a
right?
new line in.
What's happening in the right method? Look at our mobsters. It looks to me like we're reset every time we call write. We're resetting mobsters to an empty array.
Yeah.
We call it multiple times. We're not actually appending to an array. We're creating a new array and adding it. Nice.
That's interesting.
So it looks like it's writing those two in one field, and then it's going through it again and adding in a new line in the array.
Yeah, and it's also missing out the mobster Phoebe.
Yeah.
Interesting.
So you know what? I think our test is wrong actually. Our file. So this is let's do Bob/N because the names need to be
It's
on.
not a new line. Yeah.
The names need to be on their each line. So let's save that and run and see what happens.
Oh, so it was thinking we had Bob Phoebe and just doing mobster Bob Phoebe. And then,
Yep. Yep. Okay. So getting closer.
So we can probably just
join them?
you could join them and then get rid of the last. Well, yeah. I don't know whether in the test we should be getting rid of the last new line, or whether that should be part of the program. But let's join them and run, and we should see some improvement.
So what does puts do specifically? If you pass it an object, what does puts do?
It puts the line plus the character of ending the line, yeah?
So it adds a new line, right? Every time we call puts, it adds a new line. So we would expect that we should actually have a new line at the end of mobster Phoebe, right?
Oh, okay, so we can improve our expectation there. Okay.
Nice. Awesome.
Nice.
All right, let's add our stuff and commit. And we don't care about the other files, so I think we can just do git commit -a, and that will commit the files that we've already added to git.
Okay. Oh.
Unit tests. Yeah.
Hey, I got a quick question before we go. I don't know if I can ask. Where sometimes when I see tests where we have it just describe and then in it, I'll see where it'll say like for ours it would be something like describe.
Sorry.
It'd be like describe mob rotator and then another line before that, another describe and then the it before that. So it's sort of nested in describing the class.
Yeah. So this it's for the rspec syntax because if we do this currently and we run our spec and we say I think it's -fs. I meant D. Yeah.
D. Yeah.
Whoops.
Goodbye.
Okay. So what just happened? Is it not the...
M time. Is the file gone?
No, there's artspec dash F B. Weird. I don't know. That's interesting. I don't know why that blew up.
Maybe add dash F space D after
I
the.
think we've blown away the file, haven't we? A mobs the file.
It's very weird. Well, I guess I don't see why RSpec would be blowing up on this. Anyway, I don't want to deal with that right now. But basically, what we're getting at is when we print it out, RSpec will say like describe blah blah blah, it blah blah blah, and because we have nothing in the describe, it's not going to do it here. So what Rob's talking about is like if I'm structuring this particular unit test for this particular class, I would start off by saying we're going to describe the mob rotator, and then I'm going to say that we're describing show mobsters. And in here, that's where now I write my test. And then that way, it's very, when we get to the next one, we say describe rotate, we say time, right? It breaks it out, it makes it more clear, and if I knew how to run RSpec properly, then it would print out the features in a nice kind of format. It would say mob rotator does show members, and it prints out all the mobsters, right? And then there's mob rotator rotate. It rotates the file, whatever. So it's a way of organizing your test, and RSpec doesn't care actually if you have those strings. It just makes the output a little bit nicer. So any questions or comments and stuff on this? Because we're gonna wrap up and take off.
I just feel like creating the output class is very heavyweight. Is there any other thing to get around with it?
Yeah, so another approach, first of all, I disagree about it being heavyweight. I really like doing things like this. That's what polymorphism is all about, is being able to create new objects that do what you need to do. But another approach there's several things we could have done, but keeping with the structure that we have here, another approach would be to use mocks instead. And so that would be something like expect, well, let's just see if this actually works. So we'll say expect output to receive write with, and then mobster Bob
Slash n.
So because write is going to get called multiple times, I forget if this is the syntax specifically for allowing multiple calls. Anyway. So now with the expectation comes first, and we're saying that our object is going to receive this write method with these sets of arguments. And I actually suspect that's wrong. But then we call it, let's see, so it got called with mobster Bob /n. And so this is still going to fail. I forget what the exact syntax is, but I'm pretty sure that we can call this twice. And
It shouldn't be array?
Yeah, you know what? I think you're right. So this is saying we'll call it twice, and no, because how would you pass an array, right? Like if you're expecting it to be called with an array. So I think what we need to do is just do it twice. D command to delete the next character is the same as detaching from the screen, so that's not fun. So now we're specifying two expectations. We're saying it's going to get called with mobster Bob, and it's going to get called with mobster Phoebe, and that one. It's interesting. Whatever. Yeah, I know, right? The first time it has a /n, and the second time it doesn't.
Yeah.
I'm not really sure what's up with that, but I kind of don't. What just happened? got/n. So you know what? I think it's getting called with multiple ones. So if we do this, so what did I just do? I don't know if this is gonna work, but you see the general style. Okay, yeah. So that's kind of odd to me that it split out like that. But whatever, it did, and I don't know. That's in this particular case, I'd be more inclined to do the style that we did before because another thing is like we can verify the output. We verify the output specifically. You know, so instead of this join, we can just say that it equals the array, right? And we pass in whatever we want there. So it gives us a little bit more flexibility in terms of how we set up the expectation and stuff. So, but yeah, that's another approach. And then a third approach would be redirecting this to a file instead of our output object, and that is also in the very first lesson. And then that way we could just run our code and then read from the file and verify that our file is the appropriate thing. But I wanted to demonstrate this technique of using objects because that's all that is happening under the hood. This sort of stuff, like these mocks, it's just a way of automatically doing this sort of thing. It creates that kind of object for us, and so it's just it's a shortcut to that particular approach. But it's useful to understand this approach to know what mocks are doing and why you're using. Because a mock object is simply creating a fake object that responds to the interface that we want, and then automatically run some expectations afterwards.
So mocking is just a concept like that.
Yep.
Mocking. Yeah. Okay.
Yep.
Right.
So mocking combines two parts. It combines the definition of the method. So we're saying expect output to receive. So we're saying that this will have a method on it called write, and it's going to take one argument, and that argument, when it's first received, will be this particular string, and then this our expect is automatically generated by the mock. So instead of us calling it afterwards, by defining it as part of the expect here, it hooks into our spec and says, okay, when the test runs, verify all the mock objects.
Right. Okay.
Cool. So you guys, I gotta take off. We're doing an interview with Woody in 17 minutes, and we've been here for about 2 hours. So I need water and a break and stuff. But thank you guys so much. This was awesome, and it looks like we're building a kind of a nifty little tool that is going to be helpful for our mob stuff. I think that's pretty great.
Cheers, Pat.
Neato. All right, guys. We'll see you later.
Later, guys.
All right.
Bye.
Bye.
Yeah.